Hello, hello. I'm Breton, one of our MCAT tutors here at Inspira Advantage, where we help students get into med school and other professional programs. Today, we are going to chat about the trends in the periodic table that you need to know to do well on the MCAT. I'm a big believer in that if you can understand the underlying trends of the periodic table, you can apply this to a wide range of questions the MCAT is going to ask, and you'll be able to derive a whole lot of information. Let's start by looking at the periodic table as a whole. As we move from left to right on the periodic table, we notice that the atomic number, or the number of protons, increases. So the atomic number is just this 1, 2, 3, 4, 5, 6, so on and so forth. As the number of protons increases, we will have a greater pull on surrounding electrons. This trend is called the Z effective charge, and it increases from left to right. The other piece of information we need is that as we move from top to bottom, there are going to be more valence shells. These combination of facts result in a counterintuitive finding that the atomic size actually decreases as you go from left to right. This is due to the greater pull on electrons from the protons. The pull forces the electron closer to the nucleus, decreasing the overall size of the electron cloud and, therefore, the size of the atom. In addition to pulling the atom closer, we also have to take into account the amount of valence shells. So the more valence shells we have, the larger the atom's going to be. So we also have a downward trend for atomic size as well. This means, based on these trends, that the largest atom should be the actinide, since it's the furthest bottom and the furthest to the left. Conversely, the smallest we would expect then would be helium. The next important concept we want to talk about is electronegativity. Electronegativity measures the attraction of an atom to an electron. If the valence shell of an atom is less than 50% full, it requires a lot less energy to lose an electron than to gain one. Well, where is this magical cutoff point? Right here. Everything over here has a valence less than 1/2 fold. And here, to the right of carbon then, carbon all the way going down, the valence will be greater than 1/2. If the valence shell is more than 50% full, it is easier to pull an electron into the valence shell rather than donate one. The exceptions to this rule are the Nobel gases, which have basically zero ionization energy. To summarize here, the electronegativity is going to increase from left to right. Additionally, electronegativity is also going to increase from bottom up. This is because of a greater atomic radius. Now, the chemists in the audience may be squeamish here, but for the purposes of the MCAT, electron affinity is essentially the same thing as electronegativity. It's just a bit more quantitative of a number. The final trend we're going to talk about is something called ionization energy. This is how much energy it takes to remove an electron from the atom. Essentially, this is the opposite of electronegativity in concept, although the periodic trend is the same. This means that the more electronegative an atom is, the less likely it is to give up its electron, and therefore it will take a greater energy, specifically a greater ionization energy, to remove that electron. These are all the periodic trends you need to know for the MCAT to get an amazing score. For more help on raising your score, please check out our other MCAT Bytes videos or connect with a private tutor today at inspiraadvantage.com. Thank you so much for watching our video on periodic trends, and I will see you next time.